Bing! Did you even hear her that time? Did you even heard her? Jeez. Carly? What? I need you on volume 10, ma'am. Okay, so last time we talked about finding a missing side length using the Pythagorean theorem, and then using that side length to make the basic trig functions that we know. Are you guys ready?
Yes.
Did I skip you? Oh, shoot. So today we're adding on to our basic trig functions. Well, where did I put the Post-it notes? Famil. We're going to meet some new trig functions today. We are going to meet some new trig functions. So we're on page 108. We're going to use Desmos to simplify our fractions and do some division problems. So we're going to add 3 new trigonometric functions today, and these trigonometric functions are the reciprocals of these 3 that we already know. So sine, cosine, and tangent are our basic ones. They're our basic B's. And the reciprocals are another 3. So in addition to the 3 basic trig functions, we must also know their reciprocals. So that's the word that's capitalized right underneath this blank. Or sorry, right on top of the blank. Now hopefully that word reciprocal sounds familiar to you because we use reciprocals when we divide fractions. In order to divide a fraction, you multiply by the reciprocal. That's the same idea here. That idea of a reciprocal is the same thing. So these guys have their own names. They are cosecant. So C-O-S-E-C-A-N-T. Cosecant. Cosecant or cosecant. I say cosecant. Next one is secant. So cosecant, secant, and then the last one, cotangent. So he's the only one that sounds familiar. So our new trig functions that we're going to add on are cosecant, secant, cotangent. Well, what are they the reciprocal of? So first let's talk about what a reciprocal is. So sine, we know, is the opposite side over the hypotenuse. Cosecant, and we abbreviate that with a CSC. Cosecant is equal to 1 over sine. So what is the reciprocals in this case? Let me highlight. This is your trig function sine. This is its reciprocal. So we flip it. It's like a reciprocal is if we have a fraction, we flip the fraction. So if we had 3 over 4, its reciprocal would be 4 over 3. That's what we're doing here. We're taking sine over 1 and flipping it so that it's 1 over sine. So sine and cosecant go together. Cosine goes with secant. That's going to be 1 over cosine. And the only one that sounds like it makes sense is cotangent goes with tangent. It's 1 over tangent. So these new trig functions are the reciprocal of our basic trig functions. So sine and cosecant are pairs. Cosine and secant are pairs. Tangent and cotangent are pairs. So there's one very specific case where we use this situation. This 1 over sine, 1 over cosine, 1 over tangent. So flip the page and let's go to the bottom of 109. The first one that they want us to find is the cosine of 15. Well, we know that cosine is a ratio, but we have no triangle. So what are we supposed to be making this ratio out of? Well, we don't know. So what we're going to do instead is go to Desmos and use Desmos to tell us. So I'm going to get into Desmos. Hopefully you're already there. I'll adjust my thingy-do. Okay, so I'm going to choose the scientific calculator. And then luckily, all we need to do is type in COS for cosine, 15, and that's going to give us the decimal. So let's go 4 decimal places. Let's go 0.9659. Sorry, you can't see what I'm doing there. So I plugged this into Desmos. And that's what I get. Okay, let's go 1 down and do tangent. So same idea. In Desmos, all I have to type in is TAN 60. I'm going to go 4 decimal places again. So I'm going to do 1.7321. So the tangent of a 60-degree angle is 1.73. The cosine of a 15-degree angle is 9659. So some kind of fraction gave us this. Like this could have been the fraction 11 over 12, and then that simplifies down to 0.96. So it's still the ratio of 2 sides, but because they don't give us the triangle or the side lengths, we have to use our calculator. And that's why we're getting a decimal. Instead of our calculator giving us the ratio, it gives us a decimal. So it changes that ratio into a decimal. Okay, let's do the last one, number 7, sine of 50. 4 decimal places would be 0.7660. So now if we look further beyond the next 4 problems, we look at those. These are now all the new trig functions, well, besides this guy, and they are the reciprocals. So if I go to number 2 and I try to type in the cotangent of 35, it gives me that little warning triangle. So this will not do it for us. And the reason why is because we have to change it to the functions that we can do. So we can do sine, cosine, and tangent. So in order to be able to figure out what cotan is, sorry, distance learners, I'm really dropping the ball here. So in order to figure out what cotan is, we have to change it to 1 over tangent. So if we want to know the cotangent of 35, what we have to plug in is 1 over the tangent of 35. That's where we use this first set of reciprocals that we learned. If we have to plug it into the calculator, we have to change it to its basic form. So now we can type into Desmos 1 backslash tan 35, and it will compute that for us. So we write down 14281. That's not what I wanted. So we're writing down 1.4281. For cosecant, I need to do, so I come here, I find cosecant, I need to do 1 over sine. So I need to do 1 over the sine of 51. So if I flip back to Desmos, I plug in 1 divided by sine 51, not 52. So 12868. So these ones that it will not do for you, you have to change them to their reciprocal. Do you understand what you're doing? Okay, you guys try those. I'm going to try mine too. Now, I don't have these memorized, so. Okay, I'll come through and check on you. Okay, let's go approximately 30. $20. 10. Okay, so for 5, I got 2.2027. 6, I got -2. 8, I got -0.8660. And 9, I got -25593. How'd you guys do? Yeah. Okay, so I'm going to do some highlighting really quick because we're going to do something different now. And when I go back to when I go to do the quiz, I want to be able to remind myself how to do these problems over here on page 109. So we use this reciprocal formula. So this middle column, when we do problems like at the bottom of page 109. So I'm highlighting these in the same color so that when I get to these problems on the quiz, I can remind myself how to do them because this is different than what we're doing for the rest of this lesson. So I'm highlighting these reciprocals in the same color as these problems over here. In about 10 seconds, we'll move on to the next thing. About 5. Okay, so this really isn't what we've been talking about lately, though. What we've been talking about lately is SOHCAHTOA. We've been talking about the fact that the sine is the opposite side over the hypotenuse. And that cosine right here is the ratio of the adjacent side and the hypotenuse. And that tangent is TOA, and it's the ratio of the opposite and the adjacent. So how does this now relate to these new functions? Well, this is easy. Once we write this down, these problems become really easy. So if I get the sine, it's O over H, that means that the cosecant is the reciprocal, so all you have to do is flip it. Instead of O over H, it's H over O. Cosine is A over H, so that means secant is H over A. And then cotan would be A over O. So these ones are SOHCAHTOA, you just flip them for the reciprocals. The reciprocals don't have a cute little saying though. Cho-cha-cow. Cho-cha-cow. Nobody says that because you're just sounding like a dum-dum. So we don't have a SOHCAHTOA for these guys. Unless in your brain you want to do cho-sha-cow. Cow. No? No, fine. Okay, so the last part of today's lesson, we're not doing this today. Don't kill it. Just we're not going to worry about this guy today. So the last part of this lesson is combining what we learned last time, so finding a missing side, with listing all of the 6 trigonometric functions. So step number 1 on this guy is to label. So we're going to label this entire triangle based off of this focus angle. That means that 8 is my opposite side. The blank side is H, and the bottom side is A. Then last time we learned that the formula A squared plus opposite squared equals H squared can help us find this missing length. So I plug in 8 squared plus 15 squared equals H squared. And now that I have Desmos just pulled up, I can go there and do 8 shift 6 plus 15 shift 6. That gives me 289. So 289 equals H squared. Then I got to root it. So I'm going to hit my root. Nope, that didn't help me. Enter. I'm going to hit root 289. Oh, hallelujah. It's a nice number. So our missing side length is 17. There's the work. So now it wants us to list the 6 trig functions. And I find it easiest to list them like it does in the table, doing 2 columns. So I'm first going to do sine theta, cosine theta, tangent theta. Those are our basic trig functions. And that's SOHCAHTOA. So sine is 8 over 17. 17 is a prime number, so I know that does not simplify. Cosine is 15 over 17. Same thing, 17 is a prime number, so I know that does not simplify. Tangent is TOA, so 8 over 15. And that guy, I'm honestly not sure if he simplifies. Does he? I feel like he does. Somebody's double checking for me. It does not. Tried to trick me. Didn't get me though. Cheyenne helped me. That does not simplify. Okay, now our reciprocals are so easy. Cosecant theta, we just flip this. So 17 over 8, because these are reciprocals. Secant theta, we just flip this guy. 17 over 15. And cotangent theta, we just flip this guy. 15 over 8. Not too bad. Do you guys agree? Yeah? So we use the middle column when we're doing the actual value, so the decimal value. We use the third column when we are asked to give all of the ratios. So because this is very similar to what we did last time, I want you guys to try number 2. I'll help you label this angle or this triangle. So notice your theta is up top this time. So that means that your opposite side is root 21. Your hypotenuse is 5. And your adjacent side is the one that we're finding. So these sides flipped, the opposite and the adjacent flipped because the angle flipped. It's not the bottom right anymore, it's the top. So I'll help you set up the equation. We have a squared plus root 21, oh that's weird, squared equals 5 squared. Do you want me to keep going with this one? Okay. A squared. Well, turns out if you square the root of 21, the root just goes away. So if you plugged that into Desmos, if you plugged in root 21 squared, Desmos would just give you 21. Equals 25. Okay, what do we got to move? Do we move the 21 over or the 25? 21. How am I going to do that? Going to minus that guy off. I get a squared equals 4. And hallelujah, if I root both sides, 4 is a perfect square. What is its root? 2. Now that you know that, you guys go through and do these 6 functions for this new triangle. Do you know what you're doing? Okay. So I'll freeze on that side. Well, maybe I'll zoom out and freeze on the whole thing. So you're finding the 6 functions now. I'll come walk through in just a minute to see how far you are. So roughly 30. $20. About 10. Okay, so my sine, I got root 21 over 5. Cosine 2 over 5. Tangent root 21 over 2. Do those match yours?
Yeah.
Okay. And then cosecant is 5 over root 21. Secant is 5 over 2. Cotangent is 2 over root 21. So this portion hopefully is the easiest part for you because all you have to do is take these ratios and flip them. We're feeling okay about that? Okay, last part. There's really not much that's new on the last set of problems, but it's why I brought you that Post-it note. So this time, what is happening is they actually give us one of the reciprocals. And we need to find the other 5 trigonometric ratios. So they give us one reciprocal. We have to find the other 5. And then right after that, it says, pro tip, draw a triangle. So I'm going to write the steps out that are going to remind me how to solve problems like this. Number 1, we're going to draw the triangle. And I always draw the same triangle every time. So the triangle that I draw every single time looks like this. And the reason that I always draw the same one is because then I know this is hypotenuse, this is opposite, this is adjacent, and I don't have to wonder what the different sides are. Step number 2 is that I am going to label my triangle with the sides that they give me. So I should say label sides, not triangle. So label your sides. So they're going to give you 2 side lengths. You write those side lengths down. And then step number 3 will be your a squared plus o squared equals h squared. So there's one additional layer here, and that you have to set up the triangle. Okay, so I'm going to draw my triangle. Step number 1 tells me for number 3, I'm going to draw my triangle. Here's my triangle. I know that this is hypotenuse, this is adjacent, this is opposite. And they give me secant. So I'm going to use my table. I know that secant is the sides h over a. Secant is h over a. So now I know that 13 is h and 12 is a. What does that tell me? It tells me what I can fill in. So h is 13, a is 12. I'm going to find o. So I did step 1, draw my triangle. Step 2, label my sides. Step 3, use this formula. A squared is 12 plus o squared equals 13 squared. That's going to give me 144 plus o squared equals 169. Now I do the same thing that I've done on other problems like this. I got to move that 144 over. To do that, I subtract, just like I did before. So I'm going to subtract 144 from each side. That gives me o squared is, somebody do 169 minus 144. Oh, hallelujah, 25. So what's my opposite side length then? 5. So now I can fill that guy in. And now we just build our ratios. Even though they already gave me one, 13 over 12, I still set it up as the two columns. So I just go through and do sine theta, cosine theta, tangent theta. Sine theta is so that's 5 over 13. Cosine theta is ca, so that's 12 over 13. Tangent theta is toa, that's 5 over 12. None of those simplify. And now right next to it, I do cosecant theta, secant theta, cotan theta. Cosecant, I flip 13 over 5. Secant, they already gave us. It was the setup to this problem. It's 13 over 12. Tangent, cotangent, I just flip tangent, so 12 over 5. And now I have all of the trigonometric functions. You're feeling okay? Yes, no? Okay, so you do the first 3 steps for number 4, and then we'll check in. Because I don't want you to make the ratios if your side length isn't right. So you are doing 1 through 3 on number 4. We're going to set it up. I'll come walk around, and then we'll check our answers. That's a horrible number. Ugh.
I would leave it as a root. Even though it's an ugly root, I would just leave it as a root.
Okay, let's go about 30 and all unfreeze. About 10. Okay, so unfortunately, I get 377, and he's not a perfect square. So when I go through and find my ratios, so the sine of theta, he's not nice looking. He is 11 over the root of 377. You could change it to its decimal, but we usually don't do that when we're doing trig. So if you plugged it in, you should have got a decimal that was 19.4. You could use that. We just don't typically do that for these kinds of problems. Okay, take like 1 minute to build the rest of your ratios. So do all 6. about 30. $10. Okay, check your answers against mine. I'm getting 16 over root 377, 11 over 16, and then down the next side, root 377 over 11, root 377 over 16, and then 16 over 11. How'd you guys do? Okay? Okay, give your quiz a go. Shouldn't be too bad.